So here we are on the final file, Houdini file from last week, and we're gonna start from this point and start working on our sparks effect. I'm gonna hide everything that's Thunderbolt related, so just turning off the display flag, and I'm gonna go here into the geometry of Ironman. The reason I'm coming here is because this geometry, it's a good idea for us to take care of a few things before we proceed. So far, this was working great for the effects that we were generating, but we might make use of a couple of changes to this that won't affect the Thunderbolt simulation, but will be useful for the sparks effect. And one of those things is if you middle mouse button here on the file that's loading the sequence from Ironman animation, you'll notice that we don't have point normals. We only have vertex normals. And as you know, when we scatter points onto a surface or we generate particles from that surface, those points or particles will be able to inherit the point attributes that we have. And what we're going to be using is, if we have point normals on the surface, we can use that normal as a velocity for the particles that are going to be coming out of the surface when the thunderbolt hits. And that's one of the things that we want to take care of. Let's type normal. We'll apply a normal operator and just say that we want to add normals to the points. And that way we have normals on the points, and when we scatter points, we'll have normals as well, and we can then use that normal to convert that normal into a velocity. Now the other thing is, velocity on the surface is also something that we could use. It might become useful, and it's something that's usually required for motion blur and stuff like that. So one very powerful node is called trail. Let's type trail. And the trail has an option to compute velocity. Let me paste this here. And as you can see, we'll have velocity on our points. And we can have a look at that velocity by turning on the point trails. And as the name implies, this is the trail of the motion of the point. So this represents at the end of this trail, for each one of the points, you will have the position of the previous frame, okay? It's essentially that. And that's basically it. Oh, one thing to keep in mind. When there are several ways for trail to calculate the velocity, and right now we have velocity approximation using backward difference. This is great, but we'll have a problem at the first frame because we don't have a previous frame to do a backward difference. So we'll be switching this to forward difference, and that way we won't have any problems. The result is very similar, but this way we don't get an error on the first frame. Okay, let's turn off the trails. And that's essentially what I wanted to do in terms of preparing for the sparks effect. On the next class, we're going to start building our pop network.